Good morning, students. Today I am going to start the new chapter Redox reaction. So, at first we will discuss what is redox reaction. Then after we will discuss the type of redox reaction, oxidation number, what is oxidation, what is reduction, what is oxidizing agent, what is reducing agent, so on. And at last with electrochemical cell and electrode potential. So let's we discuss the definition of redox reaction. So very simply we know that definitions of redox reaction and oxidation and reduction reaction is one in which oxidation and reduction reaction takes place simultaneously. So very simple definitions, and we have already learned this particular chapter in class 10 also. So when we talk about the redox reaction, the redox RAD stands for reduction and OX stands for oxidation. Means this is reduction and this is oxidation. So when the oxidation reduction takes place simultaneously, it is considered as a redox reaction takes place. What is the classical definition? We talk about few points. Classification. At first we will discuss the classical definition of oxidation reaction. Classical definition, then after modern definitions. So classical definition, according to this definition, oxidation and reduction reaction is in terms of addition or removal hydrogen and oxygen. This was a classical definition. Means, for example, if we talk about what is oxidation, by classical definition, simply we can say that addition of oxygen or any electronegative element or any electronegative elements. For example, magnesium plus oxygen, there is addition of oxygen takes place. So the formation of magnesium oxide balance this equation. Number 1. Number 2, sulfur react with oxygen to form sulfur dioxide. Similarly, if magnesium react with or electronegative element like fluorine, according to definition, addition or any oxygen or any electronegative element, so it will become magnesium fluoride. Then after iron plus sulfur to form iron sulfide. This is the according to classical definition. So after oxidation we will talk about the reduction also. So for reduction, removal of oxygen or any electronegative element is known as reduction. So, for example, reduction, suppose we have magnesium oxide. So, when it form magnesium plus oxygen, so removal of oxygen takes place in this case. Suppose we have carbon plus water, so it will form H2 plus carbon monoxide. Here is also hydrogen removed from here. So many examples are there. SnCl2 plus HgCl2, so it will form Hg2Cl2 and SnCl4. So according to this definition, we can easily classify what is oxidation and what is reduction in terms of classical definition. And classical definition, oxidation in terms of hydrogen, removal of hydrogen or any electropositive element, hydrogen or any electropositive element is known as oxidation. For example, hydrogen sulfide, chlorine forms sulfur plus hydrogen chloride. Next example, hydrogen iodide plus oxygen to form iodine plus H2O. So on. For reduction, addition of hydrogen or any electropositive element. For example, chlorine plus hydrogen will form hydrogen chloride, and C2H4 plus hydrogen, it will form C2H6. So on. You can explain by giving any suitable example. So applying the classical definition, let's discuss the limitations. Actually, we see the limitations of redox by classical definition. So by applying the classical definition, suppose we have sodium, and when sodium treated with hydrogen, it will form sodium hydride. So according to definition, there is an addition of hydrogen takes place. Addition of hydrogen takes place means sodium undergoing reduction. It is wrong. So no, there is not a reduction takes place in case of sodium. So see what happened. There is addition of H2 with sodium, or so we can say that is sodium undergoing to reduction? No, sodium is not undergoing to reduction. So simply we can say that the reaction represent oxidation, not reduction, oxidation. Oxidation, which species? Of sodium. Why? What is the reason? What is the reason? Hydrogen is more electronegative than sodium. Hydrogen is more electronegative than sodium. So, by few example, which is the limitations of classical definition. By seeing this reaction, there is a addition of hydrogen takes place. According to rule, addition of hydrogen is called the reduction. In that condition, sodium undergoing reduction? No. Sodium undergoing. So no, sodium does not undergoing to reduction. There is a oxidation takes place. Next example we will discuss oxygen and fluorine. Suppose next example number 2, oxygen when treated with fluorine, so it will form either oxygen fluoride or oxygen peroxide, fluorine peroxide. So in that condition, 2F2, 2F2. So there is an addition of oxygen on F2. So in that condition, is fluorine undergoing to oxidation? No. Is fluorine undergoing to oxidation, students? No. So what happens? This reaction represent reduction of fluorine, not oxidation. So what is the reason behind it? Reason means oxygen is less electronegative than fluorine. So in that condition, so modern definitions of oxidation reactions came in a according to modern definition of redox. So, and it is also known as electronic concept of redox. What is modern oxidation? According to modern oxidation reaction, the modern redox reaction, simply we can say that loss of electron is called oxidation, or we can say that de-electronation means removal of electron takes place. And the modern definition of reduction is gain of electron, means electronation, de-electronation and electronation. For example, in case of oxidation, at first we talk about the oxidation. Sodium, when it lose electron, it undergoes to oxidation. Zinc, we know that metal has tendency to lose electron. So there is a oxidation of this metal takes place. In case of reduction, chlorine, by taking 2 electron, because one chlorine atom take 1 electron, so there is a 2 chlorine atom present in a molecule. So in that condition it form 2 chloride ion. Sulfur, by taking 2 electrons, it convert sulfide ion. So according to modern concept, according to electronic concept, loss of electrons and gains of electron is known as oxidation and reduction. So what are the important points? important points. So all oxidation and reduction reaction are complementary to one another. Reactions are complementary to one another. The simultaneously oxidation and reactions are termed as a reduction reactions are termed as a redox reaction. So in nutshell, we can say that in a redox reaction, number of electron gained or number of electron left. Or lost. So in that condition, we simply define the modern oxidation reaction. Whenever oxidation reduction reaction takes place simultaneously, it is termed as a redox reaction. Means simultaneously number of electron gained and number of electron lost. For example, magnesium, oxygen, it form magnesium oxide. So let's we discuss the half reaction. It is called the oxidation half reaction and reduction half reaction. At first we discuss the oxidation half reaction. Oxidation half reaction means at first we write the equation in which only oxidation takes place. So magnesium converted to magnesium ion and 2 electron lost by the magnesium. This is equation 1. And reduction half reaction. So oxygen gain electron and form oxide ion. So there is a 2 oxygen atom. One oxygen atom gain 2 electrons. 2 oxygen atom gain 4 electron. So here formation of this. So balance the number of electron in both the equation by putting the suitable stoichiometry. Suppose this is the equation 1 and this is the equation 2. So multiplying this by 2, so it becomes 2 2 4 electron and 4 electron here. So cancel the common things and write down the balanced equation. So it becomes 2 stands for all. So it becomes 2 mg plus O2. First we write the left side value O2. Then it come 2 mg plus and 2 oxide ion. So this is form magnesium oxide. So this will form magnesium oxides. So let's we discuss another method of oxidation. Whenever we take the charge present on the particular species, take as a oxidation number. So let's we discuss the third definitions of redox in terms of charge. So next one is take charge as a number. So we can write here increase in the number means charge number increase in the number is called oxidation, and decrease in the number is called reduction. Oxidation and reduction. So write the definition of oxidizing agent and reducing agent first. Oxidizing agent. Oxidizing agent. What is oxidizing agent? Oxidizing agent, the species which oxidizes a substance, which oxidizes a substance and gets reduced is called an oxidizing agent. Is called an oxidizing agent. Or it gain electron. Second thing is it gain electron. So those species which gain electron is known as oxidizing agent. Next, reducing agent. Reducing agent. So the species which reduces a substance, the species which reduces a substance and gets oxidized is called as a reducing agent. Reducing agent. Or it loses electron. So reducing agent which lose electron, oxidizing agent which gain electron. So by this you can easily find out which one species is oxidizing agent and which one species is the reducing agent. Let's be discuss through or explain through example. We have magnesium and it treated with oxygen, it will form magnesium oxide. So oxidation half reaction. At first write down the oxidation half reaction. Oxidation half reaction. In oxidation half reaction, magnesium changes to magnesium ion by losing 2 electrons. And so here magnesium lose electron, so we can say that magnesium is a reducing agent. Similarly, reduction half reaction, oxygen take 4 electrons by multiplying to 4 electrons, it will form 2 oxide ion. So here oxygen is a oxidizing agent because it gains electron. Magnesium lose electron. So magnesium is reducing agent and oxygen is a oxidizing agent, because we know that oxidizing agent gain electron and reducing agent loses electron. So in this way you can learn about the oxidizing and reducing agent. Let's we talk about the oxidation number. So what is oxidation number? Oxidation number. The oxidation number or oxidation state, the oxidation number or oxidation state, oxidation state is defined as the charge state is defined as the charge, real or imaginary, real or imaginary, which an atom appears to have when it is in chemical combination, chemical combination, chemical combination. For ionic compound, we take real charge, real charge. For example, if ionic compound taken as a NaCl, ionic compound we consider real charge, and for covalent compound, we take imaginary charge, imaginary charge. So for ionic compound we take NaCl, sodium ion and chloride ion. So oxidation number of sodium is +1 and oxidation number of chlorine is -1. So in case of ionic compound we take real charge considered as a oxidation number real charge. Suppose next example, we take hydrogen chloride. So as we know, HCl like this form, and hydrogen is less electronegative than chlorine, so hydrogen acquire positive charge and chlorine acquire negative charge. So hydrogen has lost one electron, chlorine has gained one electron in that particular case. So in that condition, oxidation number of hydrogen is +1 and oxidation number of chlorine is -1. Shared electrons are assigned to the more electronegative atom. So electron share. So in the condition of shared electron, oxidation number assigned to more electronegative atom. So in that condition, shared electron as a more electronegative atom. So here is the -1 chlorine and +1 hydrogen. So write down the rules for assigning oxidation number. Rules for assigning oxidation number. First rule: the oxidation number of an atom the oxidation number of an atom in free or uncombined elemental state is 0. For example, oxidation number of fluorine F2 is 0, Br2 is 0, phosphorus in P4 is 0, oxygen in ozone is 0, chlorine in Cl2 0, sulfur in acid is 0. So oxidation number of atom: bromine in Br2 Oxidation of atom in free state or uncombined elemental state considered as a 0. So the second rule, number 2, the oxidation number of fluorine is always -1 in all its compound. In all its compound, because we know that fluorine is more electronegative element in our periodic table. So third rule is the oxidation number of oxygen is -2 in all its compound except in peroxides, where -1 charge is assigned, superoxide where -12 charge assigned, and in case of oxides of fluorine where -1 for fluorine and +1 for oxides and -1 for fluorine, because oxygen is less electronegative than fluorine. In that condition, for a plus charge appear on oxygen and minus charge appear on the fluorine. So we see here the range changes -2, 0 to +2. So next we discuss number 4. For example, we discuss example of peroxides. We know that H2O2, sodium peroxide Na2O2. So here the -1 oxidation state assigned on the oxygen, and in sodium peroxide -1 oxidation state of oxygen. In case of superoxides, potassium superoxides, rubidium oxides. So in that condition, -12 oxidation state assigned over the oxygen in case of superoxide. In case of simple oxides of fluorine, oxygen dichloride and O2F2. So in OF2 +2 and O2F2 +1 oxidation state assigned, because fluorine is more electronegative than oxygen. So plus charge appear on the oxygen and minus charge appears on the fluorine. So this is our third rule. Let's discuss the fourth rule. So fourth rule is the oxidation number of hydrogen is +1 in all its compound except metallic hydrides where oxidation number is -1. NaH, here sodium is metal, so plus charge appears on the metal and minus charge appears on the hydrogen. So in case of HCl, so chlorine is more electronegative. In that condition, +1 is appears on the hydrogen. So oxygen, all its compound, it acquire +1 except metallic hydride. With metallic hydride, hydrogen always acquire minus charge because metal is more electropositive than hydrogen. In that condition, hydrogen is electronegative than sodium, so minus charge always appears on the more electronegative species. In that condition, negative charge appears on the more electronegative element. Next rule is number 5, the oxidation number of alkali metal. Alkali metal means group 1 metals is always +1, always +1, and the oxidation number of alkaline earth metal means group 2 alkaline earth metal is +2, is +2. Next rule is the sum of oxidation number of all atom in a species is equal to the net charge on the species. Oxidation number of all atoms in a species is equal to the net charge on the species. Net charge on the species. For example, we talk about the example KMnO4. This is a neutral molecule because no charge assigned on this molecules. It is called the neutral molecule. Neutral molecule. So suppose we find out the oxidation number of all. So at first, oxidation number of potassium plus oxidation number of manganese plus number 4 into oxidation number of oxygen equal to 0. This is the 6th rule. In the condition of dichromate ion, for example, we take another example, Cr2O7 minus 2. This is the polyatomic ion. It is called the polyatomic ion. So by calculating oxidation number of chromium plus 7 into oxidation number of oxygen equal to minus 2. So this is our 6th rule. So that is enough for today's class, students. So next we will discuss in the next video. Thank you.